Hello, I'm Josh, and I'm going to do some C2 maths. Yeah, no, this is, yeah. Alright, today I'm going to be doing some Factor Theorem. Alright, and basically the idea of Factor Theorem is, let's say you got yourself an equation that is, let's call it, function of x, fx. Let's say that fx, that is equal to
2x cubed plus 5x, minus, should we say 5x squared minus 4x, and minus 3.
Let's say that we know, somehow the question tells us, that x minus 1 is a factor of this equation, right? Now, we can show that this is a factor by substituting in the 1 here. Because in any polynomial, that's what this is called, it's a polynomial, we can, if we know that this is a factor, we can do this. We can do f1, and so basically we just sub the 1 into the x, so
2, 1 cubed plus 5, 1 squared minus 4, and minus 3.
And that in turn will give us 2 plus 5 minus 4 minus 3. And if it is a factor, then, oh, there we go. 5, 7, minus the 4, minus the 3, so that would be 0. Basically, whenever you need to use the factor theorem, just remember that if it tells you it's not even minus 1, or it could be a plus. Basically, when x minus, let's just call it a, so when a is a factor of fx, you simply just substitute a in. So let's say this was a plus, you sub in a minus. But then if we went ahead and did that, then this would just be, I don't know, something else entirely.
Where's my board rubber? I could get my board rubber. I should have been more prepared for this. Damn. There we go. Box of board rubber. There we go. How's your day? I don't care, I'm just asking anyway. Which nicely leads us to remainder theorem. Now, I'm going to go quickly right here. So, remainder theorem. Right.
Same basic idea, like the whole dividing, an equation with another expression. Now, let's say you come up with a question, and it tells you that
2x cubed minus 3x squared minus 2x plus a,
an unknown variable, but the question tells you that this expression, this equation, divided by x minus 1, you're told that it will give a remainder of minus 4. The way we go about this is we simply take this expression here, and similar to the factor theorem, we basically take the 1 here and we sub it into fx.
So f1, so that will just equal cubed minus 3, 1 squared, minus 2, 1, and then plus this a.
And that will equal this remainder here, minus 4, right?
And this is just 2. And this here is just a 3, that's also just a 2, plus a.
Now we know that's minus 4. Now we don't know what a is, but we can find out what a is by quickly rearranging it. So this minus 4, plus the 2, plus the 3, minus the 2, will be a is equal to minus 1. So basically, when you find out that a is equal to minus 1, just to double check it, I suggest, you don't have to, but I just go ahead and do it anyway. Go and sub in, a into the original equation, and see if, when divided by this x minus 1, see if it really does give you the remainder of -4. And if you're not entirely sure on how to divide equations by expressions, you know, the x minus 1, fear you not, I will show you how.
Okay, so
let's start with an equation, you know, that will factor. You know, just to make this pretty simple. Now, I'm gonna trust you and just go ahead thinking that you probably already know the bus stop method. If you don't, I'll just listen very carefully. So, bus stop method is, well, I don't completely understand it myself, but this is more or less how it works. So, you have your your equation, which is 2x cubed plus 5x squared minus 4x minus 3. And you want to show that the expression x minus 1 is a factor. And this is what you do. What you do is you write it out properly. Alright, so first, this x, we see how many times it goes into 2x cubed. Now, we know that 2x squared times by the x will give us 2x cubed. So we're going to write 2x squared up here, right? This is what we're going to do. We're going to times this by this to then write the 2x cubed down here. Alright, we then times this by the -1. So then we do -1 times by 2x squared to give us minus 2x squared, right? And then what we've got to do is we've got to basically take away this line from that line. So 2x cubed minus 2x cubed, well, that's just going to be nothing. But 5x squared, take away a negative number, so -2, that will give us 7 squared. And then we bring this -4 down. -4x. This is just for later. But basically, it's at this point that it's just a whole process of rinse and repeat. So, again, how many times does this x go into 7x squared? Well, precisely 7x times. Because 7x times by x will give us 7x squared. Anyway, next step. You know, we do the 7x times by the x to give us 7x squared. And then we times the -1 by the 7x to give us minus 7x. Anyway, take them all away. So 7x squared minus 7x squared, it's nothing. Good. Minus 4x minus the minus of 7. So what we're actually doing is -4 plus 7, which is 3. Yes, it is 3. 3x. Good. Alright, and then we just bring this one down here. Alright, good. One more time. Alright, how many times does x go into 3x? Well, it just goes in 3 times. So we're going to write plus 3. Alright. Now, we do the same thing again. 3 times by x, well, that's 3x. And -1 times by 3 is -3. Take them away, it's nothing. And when that's nothing, you know that this factorizes into that to give this. Oh boy. Now usually, when you're asked to factorize a big-ass long equation like this, that you know you'll get this, and then you'll be left with that. And then probably the next part of the question will be like, well, just go on, keep on factorizing it. And at which point you're going to be like, alright then. And basically, what you're then going to write is, you know, this, well, that's basically just equal to x, that, and then this, which is 2x plus 2x squared plus 7x plus 3. And then you just, you know, factorize this quadratic. Now, if you watch my earlier videos, you probably know how to factorize a quadratic, but I'm gonna just briefly show you. This coefficient of x squared here, well, that's a 2, and you know, factors of 2, well, that's just 2, 1, minus 2, and minus 1. But you know, because they're all pluses, I'm just going to hazard a guess that the factor here is going to be 2 and 1. You know, so in that case, we're going to write 2x, close bracket, open bracket, x, close bracket, and we'll leave these spaces open. But at least we know that this times that will give us the 2x squared. All right, next part. Now, factors, we need to figure out these next two. All right. It's good if you quickly figure out the factor of 3 here, because once you've done that, you can basically just jot these numbers in, because all you know is that these two numbers here, they're going to times to make that number, but they're going to add up to make this number. But we got this 2x here to complicate things. But don't worry, because it's 3, and 3 only has like, well, it's a prime number, which makes it even more fucking terrific. So, in which case, we can either write +1 and +3, but if we do that, we can immediately see that if we were to times 2x by 1, that would give us 4x, but then if we were to plus 3x, that would, 2 plus 3, it's 5x. No, it doesn't work! So in which case, you basically say no, and you get a board rubber, and you quickly rub them out, and you switch them, and then you realise that this is probably the right answer. And you know it's the right answer because 2x times by 3 is 6x, and plus the another x is another 7x, and it all works out beautifully. And you drop your board rubber because you're an idiot. But essentially, this is the answer that you should get. Beautiful. So yeah, that was Factor Theorem and Remainder Theorem. I hope you enjoyed that. I did, I think. I don't know. Let's do some maths and see what happens.